Guys, Mr. Gucci here. I realized I never made you a help video for the Fission and Fusion homework that is due on Monday. So I'm going to crank that out right now. If you didn't get this done in class or if you were absent, I hope this video will help you get this done. It really is, despite the number of problems here, a pretty straightforward homework. Let's get started on it. So first thing you do, there is no online worksheet for this, unfortunately. You have to do it on a separate sheet, which means you'll have to either show me your homework manually on Monday or maybe submit a picture of your work. But here is the PDF. And so you will just do your homework off of this on a separate sheet. Another option for you, if you guys remember this tool from last year, you can open up this PDF with Cami. All right, there's a little corner open with Cami. So you might recall that Cami is an app that we installed last year that allows you to edit PDFs directly. So if you want to do that, that would be pretty cool. All right, so anyways, here we go. I've opened Cami. Let's take a look. So here's how fission and fusion work. All right, in a nuclear reaction, you are either combining smaller atoms together to make larger atoms, or you are taking larger atoms and breaking them apart into smaller atoms, or some combination of that. Conservation of mass and matter still holds, so however many protons you're starting with, that's how many protons you're going to end with. And whatever mass you are starting with, that is the mass you are going to end with. So while it looks complicated, really this is nothing more than simple addition and subtraction problems with the added twist that you might need to have up a periodic table. Let me pull up an online periodic table. You should pull one up as well, or just take out your physical periodic table that I handed out at the beginning of the year. So anyways, let's get going. So first question here, we are combining a hydrogen atom with another hydrogen atom. What do we make? Well, remember conservation of mass and matter. So this hydrogen has one proton, all right, and we're adding another proton. So whatever we produce on this side is going to have two protons. All right, this atom has a mass of 1 AMU. This atom has a mass of 3 AMU. So put them together, we have a mass of 4 AMU. Now, you still need to figure out what exactly this atom is. Fortunately, it's pretty easy. All right, what we see here is that this bottom left number, the atomic number, the number of protons, is 2. So we'll just go to the periodic table and look up the second element. All right, element 1 is hydrogen, element 2 is helium. So we produce a helium atom. So we combine two hydrogens together and we make helium. And in case you're interested, this right here, this is the nuclear reaction that powers helium, He, wah, wah. This is the nuclear reaction that powers our sun. All right, the sun, the core of the sun smashes two hydrogen atoms together and produces helium. All right, that's where the helium in the universe comes from. It's the leftover fuel from stars. Let's take another problem. Let's take a look at problem number 2. So in this case, we have beryllium, and we are smashing it together with a helium atom. Again, don't get confused by all the symbols here. This is just an addition problem. I'm going to do this one in purple. All right. So this beryllium has 4 protons. We smash it together with a helium, which has 2 protons. That's a total of 6 protons that we're producing here. All right. This beryllium has a mass of 8 AMU. This helium has a mass of 4 AMU. 8 plus 4 is a total of 12 AMU. Now, what element is this? Well, it's atomic number 6. It has 6 protons. So I'm going to just pull up my periodic table and element number 6, 1, 2, 3, 4, 5. This is carbon. This is how carbon is made. All right, so let me go back here. This is carbon. So you see, this ain't so bad, folks. This is just a simple addition problem. Now, I might, because I can be a jerk, switch up the order on you a little bit. So let's take a look at problem number 4, okay? Now we see here that we are taking a nitrogen atom and we are combining it with something else to form a magnesium atom. So here, this is a simple algebra problem. All right, a simple algebra problem. We have 7 protons. We have to add it to some number of protons to get 12 protons. So this is just a simple algebra problem. 7 plus what number gives us 12? Some of you guys who are strong on your mental math are screaming out, oh, Mr. Gucci, it's 5. All right, like this is a Dora the Explorer episode. Yes, you're right. The answer is 5. All right. You need an atom with 5 protons. Now let's take a look at the mass here. All right. The mass. So you're starting with an atom that has a mass of 14 AMU. You add some mass to it, and you get 24. So 14 plus what number gives us 24? All right. You subtract 14 from both sides. Turns out the answer is 10. All right. So yes, you are producing an atom with an atomic number 5 and a mass of 10. What atom is this? What element has 5 protons? Well, I'll go to the periodic table. 1, 2, 3, 4, 5. Element 5 is boron. So this is boron. If you smash a nitrogen 14 atom with a boron 10 atom, you get magnesium, right? That's where magnesium comes from. Let's take a look at another problem here. Let's see here. What would be a fun one? What would be a fun one? Let me pause while I think of one more sample problem to do for you guys. Oh, okay. Let's do number 13 right here. Let me choose another color. Red. All right. Number 13. So this one's a little bit tricky, all right, because we have a silicon atom plus this hydrogen yields a silicon atom and something else. So again, guys, this is just a simple algebra problem with addition. All right. Remember, conservation of mass here. All right. 14 protons plus 1 proton is going to yield 14 protons plus what? 14 plus 1 equals 14 plus, and you're saying, so is it 1? Does that make sense? Yes, it does. All right. So you have 1 proton over there. Now, the other side, the top portion, a little bit trickier. This atom, this silicon, has a mass of 28 AMU. This hydrogen isotope has a mass of 2 AMU. We produce a silicon with a mass of 29 and another atom with a mass of what? So we're actually going to write this out. 28 plus 2 equals 29 plus what? All right, well, 28 plus 2 is 30. 30 equals 29 plus, you guys all know this is 1. All right? So you produce an atom with 1 proton and a mass of 1. What element is this? Once again, it's atomic number 1. So let's go to the periodic table and look up the first element. Ta-da, it's hydrogen. So, maybe like, Mr. Gucci, was this a nuclear reaction? And it was, all right? What actually happened here is that you had a silicon atom that interacted with a hydrogen 2 isotope, and what ended up happening is that the hydrogen transferred over one of its neutrons to the silicon atom. So the silicon now became 1 heavier. It went from a mass of 28 to 29. And the hydrogen atom became 1 AMU lighter. It went from a mass of 2 to a mass of 1. So guys, this is just how it works, all right? This is just a simple addition problem. You have to just make sure that the number of the number of protons on both sides of the arrow here is the same, and that the mass is equal on both sides of the arrow as well. This is just a conservation of mass problem. That's pretty much it. Just send me a message if you got any questions, guys. Good luck. See you on Monday.